All right. Hey everyone, Miss Lastly here again with some more videos. Today we have a super exciting video. Just kidding. It's still Unit 1, so it's not that exciting. But we are going to talk about something that some of you may have never seen before, which is the piecewise function. So at least it's new information that will broaden your mind to the math universe. Anyways, it's kind of interesting. I think piecewise functions are I don't know, they're kind of cool because basically it can be anything you want it to be, which is what makes piecewise functions kind of exotic, right? So let's just check them out. All right, so first off, we got to define these piecewise functions, but they really are kind of exactly what they sound like. So a piecewise function is basically a function that comes in separate pieces, which I don't know, maybe doesn't make very much sense, but basically it's just when you have more than one equation that's being defined by one like single kind of problem or function. This is used a lot in word problems. So if you have a problem where like maybe like a real life situation, so say you go to the doctor's office, okay, and then they say, I don't know, the first 10 minutes with the doctor cost you 20 bucks. And then from between 10 minutes and like 20 minutes, it's going to cost you 10 bucks plus $30. I don't know. Or $20 plus the $30 extra. And then any visit longer than 20 minutes is something completely different. Like maybe the 70 plus like whatever per minute after that. So I don't know. But that would be a situation where you have like different time increments are going to be represented by a different like value. Well, that's a piecewise function because that function comes in separate pieces. So there is a way to create one function that includes all of those different parts in it by basically separating out your domain. So that's what a piecewise function is. All right, so we're just going to give it a quick definition. So it's a function that is defined by two or more equations over a specified domain. Okay, so like I said though, it's a function that has different parts to it. And so for each x value, you may have a different equation that you're going to plug in to find your y value. All right, so basically all we're doing today is we're going to look at an example. We're going to talk a little bit about calculator and how you can actually put a piecewise function into your graphing calculator. But yeah, let's just kind of take a look at this. So here's our function that we have. All right, so it says fill in the xy table and then graph the function. So our function f of x equals all three of these different equations. It's x squared, but only if x is less than 1. It's 5 only when x equals 1. And it's the equation negative x plus 6 if x is greater than 1. So for each different equation, we have a set domain that we are allowed to use. So let's kind of get into it. So first things first, since we're going to the table next, right, because we want to fill in the table before we try and graph this, we are going to, what I like to do is kind of highlight. So we'll say we're going to use this equation, all right, if x is less than 1. All right, now this is going to require you to remember a little bit about graphing inequalities, which are the less than equal to, greater than or equal to, those things. Hopefully you remember that when you graphed inequalities, you, so say you wanted to graph like x is less than 3. And they taught you to do this, at least I was taught to do this with like a number line. So like 1, 2, 3, 4, so like 2, 3, 4, 5, like that, right? And so if you wanted x is less than 3, you would go to 3, you would use an open dot because it's less than, and then your arrow would go this direction, right? And then if you had, let's say x is greater than or equal to 3, you would graph it like this. You would go to 3 and you would do a closed dot because it's equal to, and then you would do everything on this side because it's greater than. All right, so I know that was probably really calling on some information you guys did a really long time ago, right? Graphing inequalities. But that's kind of a very similar technique that we're going to use. So the thing to focus on right here is this part. All right, so when x is 3, how do you represent that? So if it's x is less than 3, we use an open dot. If it's x is less than or equal to or greater than or equal to 3, you use a closed dot because we are including that point. And then it goes either, greater than one direction or less than, it goes the other direction. Well, that's really the same kind of technique that we're going to use for these problems with our piecewise functions. So when x squared, we're using that equation every time x is less than 1. All right, so that would be -2, -1, 0. And we also want to know what it's doing at 1 because we're going to graph it just like we did with this little inequality thing all the way up to 1, but then we'll use an open circle at 1. So we're going to use one of these ones to figure out what it's doing there. All right, next we have this middle equation, which is it's 5 if x is exactly equal to 1. So when x is equal to 1, we're going to use that equation. All right, and then our bottom equation is saying we're going to use the equation -6, or negative x plus 6 for all x's from 1 and onward, but we're not including 1. But we do still want to know what it's doing at that point 1. So for these three, we're going to go ahead and we're going to use that bottom equation. All right, so let's just go ahead and plug in some x values. All right, so -2. So if I want to know what x is at -2, I'm plugging it into that brown equation that I highlighted. So I'm going to go -2 squared. That's going to give me +4. All right, -1 squared. That's going to give me +1. 0 squared. That's going to give me 0. And then 1 squared gives me 1. So 1, 0, 1. And remember, this is going to be an open dot. All right, so I'm going to go ahead and I'm going to plot this. So -2, +1, 2, 3, 4. And then -1, 1, 0, 1. And then instead of a closed dot, remember we do an open dot. Get rid of this little mark from me trying to count. All right, so I can go ahead and graph this. This is just my quadratic function, and it does continue going because it's for all x's that are less than 1. So it includes all the negative x's also. So we do use an arrow at the end of this graph. All right, next we're going to jump to that when x is exactly 1, which is just a point, right? This is, well, technically, if the whole thing is a line, right? It's a horizontal line. But we're saying just at this one point because x is only going to equal 1 at one spot, right? It's going to be 5. So I'm going to go ahead and it's 5. So on my graph, I'm just going to plot that point, 1, 5. 1, and then 1, 2, 3, 4, 5. And it gets a closed dot. All right. Next, we have when x is greater than 1. So we start at 1 and then we're going to use an open dot because it's not included, but everything after that is included. All right, so we'll do 1 first. So if we have negative x plus 6, so -1 plus 6 is 5. So we have an open circle at 5. I thought I made this different. It's okay. We'll just go with it. I thought I made it so it didn't overlap, but apparently I'm an idiot. It's fine. This is already the 4th time I've recorded this video, FYI, and I've been changing this problem to make it work better. And I still broke it. It's okay. I'm not recording it again. So this is just our last take. Oh, I hope you guys really appreciate these videos because they are not the easiest to make. Okay. Here we go. All right, so then we have -2 plus 6. That's going to give us 4. And then we have -3 plus 6, which gives us 3. So this is 4 and this is 3. All right, so when we go to graph this, we are going to do a green. So we have at 1, it's 5. So I'm going to do a green open circle right around my closed circle. All right. And then I'm going to graph this in green. So then we have 2, 1, 2, 3, 4. And then we have 1, 2, 3, 1, 2, 3. And this is going to keep going this direction. So it gets an arrow. All right, so I didn't mean to do the overlap, but that's what you would do if it did overlap. All right, you would just do an open circle around the closed dot that you already have. Even our closed dot is in a different color. All right, and then you would just do the rest of the line going that direction. All right, so I didn't mean to overlap, but like I said, I'm not doing this video again. This is what you get. But yeah, so there is our equation graphed. Now, you can use your graphing calculator to do piecewise functions. You just have to be able to restrict your domains like we have here. And I'm going to show you guys really quick. Now, this also works in Desmos. I don't exactly know how to do it in Desmos, but I'm pretty sure a quick Google search will pull it up for you. I know Desmos does this. You guys use this technique graphing Desmos in Algebra 2 last year when you did your transformation project in Algebra 2. So I know that you do know how to do this if you did that project, right? So anyways, let's just look at the calculator. I gotta find my mouse. All right, here we go. Okay, so here's my calculator. We want it to go ahead and do this same graph. So what we're gonna do is we're gonna go to y equals. All right, so you can't see me typing the keys because it takes up too much space, but it will tell you down here what buttons I push, but I will also say them out loud. So we're gonna do y equals, to see I hit y equals. All right, and then we're gonna type in this first equation. So all we need to do is use parentheses and then type in x squared, close parentheses. So there's our function. So the first parentheses gets the function, like the equation, I guess you could say. It's not really the whole function, it's just a piece of it. And then the second parentheses we're gonna use is going to be where we put this x is less than 1. So you open up another parentheses, you type in an x, same x that you used to do the x squared. And then to get the less than symbol, you're going to hit the second and then the math button. All right, so it's where it says test above it, right? So in blue, it'll say test. All right, and so then we want it to be less than. So we're going to go ahead and click 5 and 1. Close your parentheses. All right, so now if I go check, just to make sure, see how my graph, it graphs my quadratic and then it stops right there. Now, the calculator doesn't do like open or close circles. If it does have that feature, I don't know how to do that. So anyways, it graphs my part of my quadratic and then it stops right here. All right, so it's looking good so far. All right, so I'm going to go back into y equals. So then the second thing I'm going to do is I'm going to do parentheses and it's going to be 5. And then this is for when x equals, so second math again, equals, so 1, 1, close my parentheses. Now, this one's kind of lame because it doesn't really plot the point, which is kind of silly. So you're not going to see it have like a point there. So that's really the only kind of obnoxious part about graphing on your calculator is that if it's only going to happen for like a single point, it's not really going to show it to you on the graph. I don't know why it does that. You'd think it would be able to handle just putting a dot on the screen, but apparently it can't. So anyways, going down to the third equation. All right, so we're going to put that one in. So again, we put parentheses and then we do negative x. Now remember to use the negative sign, not the minus sign. People get them mixed up all the time. When you're doing a negative, if you use minus, it's not going to work. It's going to say you have a syntax error. So plus 6, close parentheses, and then open it, x, second, math. And now we're doing for greater than, so 3 and 1 and graph. All right, so now it's going to give us that extra piece. And again, it doesn't do the open or close circles. It just does the line. So the only thing we can't really see is that when x is 5, that little point, but it still gives you a pretty good idea of what your graph should look like. Now, if you go to your table, so second table, it's going to have the right values in here. All right, so we see that for the negative values, we're using that first equation. When x is just 1, we're using the middle equation. And then for values greater than 1, we're using this last equation. So you can kind of see how in the table feature, at least, maybe it doesn't do it all the way on the graph, but in your table, you can see what is kind of happening at your different values. All right, so it's kind of a nice feature. That is how you do it. So really you just use a separate set of parentheses, and then you use that second math button to get all of your less than or equal to, all those buttons, right? But yeah, that is it. That is what I had for today. Those are piecewise functions. I think that they're kind of neat functions. They don't pop up in a lot of math classes. You'll see them again in calculus, so definitely make sure you at least remember the different parts there, right? Make sure you understand, like, okay, I'm graphing all the way up right here until x is greater than 1. For the middle one, I'm graphing it to when x equals 1, and then for the bottom equation, it's x is greater than 1. So it's all the values 1 kind of in upwards. And yeah, that's it. So today you will just have some practice on graphing piecewise functions. Other than that is it. That was our video for today. I told you it was going to be pretty short as far as my videos go anyways. Hope that was helpful. If you have any questions, let me know. Bye guys.